The sun swallows the field of view and turns sensor wells white, while 3IATLAS threads the furnace of perihelion, and for a few taut hours the world pretends to have no witness. So the first question is simple and cold. What can a concealed traveler choose to do when no one can look? We begin with a cascade of unresolved points that refuse to align cleanly. An amateur observer in the Atacama reports that the familiar hiss of local radio bands goes strangely quiet during the inner window, a pattern they have not logged on ordinary nights. A graduate student in Arizona watches nightly tracking pages update early, then hold in place until morning, as if the schedule closed its eyes on purpose. A European operations log, allegedly redacted, sketches a rehearsal that starts, pauses at perihelion, and resumes when the heat has passed. A late October coordination bulletin outlines a measurement exercise to improve cross-checks and calibration across stations. Yet, its timing kisses the exact hours when seeing is worst, and patience runs long. None of these fragments prove anything. Together, they sound like a script meant to move many quiet hands at once. This channel keeps a calm watch on such puzzles. We tie verified physics to cautious speculation and let imagination sketch only along the edges where data thins. We drift at the pace of sleep, without panic, and listen for patterns that might connect a plain memo to an unusual sky. If the riddle is thin, we say so. If the riddle holds, we follow it gently. If you value long form and low noise, press subscribe and let the cadence guide you through the dark. Share notes in the comments, especially times, instruments, and locations, so we can compare them without bias. If you operate a small observatory or listen on a radio dish, tell us what you saw or did not see, and what you expected to see. Like this video if the soft approach helps you think while you rest. And consider joining the community that collects these quiet reports for future watches. Now, dim the lights. The closest approach to the sun is called perihelion, and around that point the solar elongation can shrink to only a few degrees. Glare defeats optics not designed for daylight. Thermal loads grow to tens of thousands of watts per square meter, and telemetry windows narrow. Light takes about 8 minutes to cross 1 astronomical unit, so confirmation always lags. This is the blind arc. It is not absolute, yet it is thick enough to hide a small experiment and long enough to delay an announcement. 3IATLAS is modeled on a hyperbolic path, slightly above 1, which means it is unbound and will not stay. Its chemistry and dust likely formed under another star, so any outgassing, color, or flare it shows belongs to a biography that is not local. Interstellar travelers are not threats by default. They are puzzles by default, and puzzles deserve attention. So we ask why a coordinated drill rises exactly now, and why the language is tidy, careful, and oddly non-specific. Hard anchors steady the mind first. Coordinated campaigns happen around unusual targets to improve astrometry, photometry, and spectral coverage, while avoiding duplicated effort. They also provide a neutral channel that can carry sensitive chatter behind plain nouns. Grounded speculation walks in after the anchors. If you wanted to measure a tiny change in velocity, you would bracket the blind arc with precise positions before and after reappearance. You would synchronize clocks to small fractions of a second across several longitudes, agree on filters and cadence, and schedule a verification sweep within a day or two. You might pre-clear time on instruments that rarely take targets of opportunity. From the outside, this looks like an exercise. From the inside, it behaves like readiness. Numbers cluster for comfort. Elongation near perihelion can sit under 5 degrees. A modest push there could change speed by a few meters per second, which becomes thousands of kilometers of position drift over days. Subarc second astrometry can reveal that drift if you have enough baselines. 10 observatories spread across longitudes, reduce weather risk. 2 or 3 in the south catch windows the north will miss. 1 narrowband receiver listens for order in the static, and 1 spectrograph watches for fresh lines in the coma. No single datum would prove anything. The pattern would whisper, here the imaginative leap is small, and then it sets itself down. Picture a device that sleeps in the cold and wakes in furnace light. It does not break physics. It leans on them. A thin sail that tightens under radiation pressure. A coating that outgasses in a shaped plume when heated. An Oberth-style maneuver that stacks velocity upon velocity inside a deep gravity well. You would not test such designs when every telescope can watch. You would wait for the sun to draw the curtain for you. History offers natural counterpoints, which keep us honest. Comets do brighten without engines. Fresh ice can open, fragments can shed, spins can change, and stress can break a nucleus in sudden light. Those events imitate intention from far away. They need no plan to look dramatic. This is why language matters. Calling a mobilization a drill buys deniability, while it unlocks schedules and budgets. It also keeps the public calm if nothing strange occurs, and it keeps options open if something does. The question we hold without tightening our grip is simple. Is this prudence, or is it cover? Foreshadowing lives in the negative space. High-resolution eyes in Mars' orbit sometimes look outward and gather images that require careful calibration before release. A gap in public posting can be routine engineering time, and it can also be a choice to wait. 2 meanings can fit 1 silence, and only later does the pattern choose. For now, we keep both possibilities on the table and keep our breathing slow. We will spend the next chapter reading the coordination memo itself, because the nouns inside it will tell us how to listen. If it is genuinely a class in measurement technique, the verbs will be simple and the goals modest. If it is preparedness with a polite label, the verbs will emphasize timing, reconciliation, and immediate post-event checks. Either way, the hours around perihelion are short. Geometry constrains them, and the recovery geometry begins as elongation grows. If the first positions after reappearance match earlier fits, the sky will relax. If the fit nudges by a small margin, the sky will sharpen, and we will check again. Nothing in that outcome requires panic. Something in that outcome might require attention. One vivid image holds the mood as we close this opening. Imagine a glass wall of light, with the sun on one side as a tidal shout, and banks of instruments on the other side blinking and waiting. Between them, a small body turns a little, and vents a little as it crosses the hottest part of its long path. It can choose nothing and still look strange. It can choose heat and still look natural. What would you hide behind a star if your design needed a furnace to move? How often does nature make us imagine a hand where there's only heat and rock? Both questions sit quietly beside the same watch window, and both can wait while we go read the script that names preparation without admitting purpose. We mark the time, we let the glare thin, and we move to the words that explain a mobilization as training. In the next piece, we will open the exercise and test whether its calm language is a veil or a lesson. We open a plain document with careful nouns, a coordination note that promises calibration and cross-checks, a schedule that stretches like a net across the hours when seeing is worst. IAWN is a real consortium for planetary defense, a clearinghouse where observatories share ephemerides, photometry, and alert notes. In normal seasons, the language is simple and routine. Tonight, the memo reads like choreography. It invites stations to align clocks, to agree on filters, to submit astrometry in narrow windows, and to reconcile results within a day. It calls the work an exercise. The verbs point to readiness. The tone is not wrong. Coordinated campaigns do improve measurement quality, reduce duplicated effort, and protect coverage when weather or daylight eats the night. A blind perihelion window is a good moment to practice bracketing a target before and after glare. Hard facts sit here, and they sit calmly. A network like this exists to make many small eyes behave like one large mind. Yet the memo's cadence raises a different eyebrow. Timing is everything, and the timing kisses the hours when 3IATLAS disappears. The checklist emphasizes immediate post-event submissions, priority queues for recovery frames, and contingency slots on instruments that rarely host targets of opportunity. The map in the appendix, imagined but plausible, shows color blocks over southern latitudes, where elongation opens first, and over low longitudes, where dawn can still catch the sky. It reads like practice. It also reads like intent. A vivid image helps us feel the stakes. Picture a wall of dry text pasted to a lab door at midnight. The paper smells like toner. The title uses a spare sans serif. Beneath it, short lines that mean more than they admit. Window A. Window B. Submit within 2 hours. Reconcile positions. Report significant residuals. A stapled page lists radio listening slots for narrowband checks. Another lists spectrograph runs to look for fresh lines if the coma changes. Nothing on the page uses the word concern. Everything on the page behaves as if concern is assumed. 2 grounded speculations follow the anchors. First, if you wanted to measure a tiny velocity change from an Oberth-style push, you would bracket the blind arc with high-precision astrometry, and you would want those numbers fast. Second, if you worried about natural fragmentation or a deliberate release of companions, you would schedule overlapping fields and cadence so that faint secondaries are not lost in the recovery rush. Neither speculation breaks from normal science. Both sit comfortably under the label exercise. Here is the imaginative leap, and then we set it down. Suppose the memo carries 2 layers, one public and one quiet. The public layer drills measurement technique. The quiet layer reserves assets and attention for a device that wakes in heat and rests in cold. A thin sail that stiffens under radiation pressure could bend a path by a few meters per second. A volatile coating could vent in a shaped plume when the furnace opens. In either case, the network would want to look, quickly and precisely, the instant the curtain lifts. Hard numbers cluster to keep the mind steady. Near perihelion, solar elongation can slip under 5 degrees. A change of only a few meters per second at closest approach becomes thousands of kilometers of a long track drift within several days. Subarc-second astrometry across 10 or more sites can expose that drift. 2 or 3 sites in the south catch prime geometry before the north wakes. A dedicated radio dish listening for narrowband carriers can flag artificial order. A spectrograph on a mid-sized telescope can test for fresh emission lines if the coma chemistry flips. Silence has its own structure. We know that high-resolution cameras in Mars orbit sometimes look outward, and their frames require careful calibration before release. We know that ground-based campaigns often delay raw data to avoid confusion. Those are normal reasons for quiet. The same shape of quiet can also mask a choice. The document's verbs lean toward urgency and orderly haste. The calendar entries line up like teeth. When language and timing agree this neatly, it becomes hard to tell where prudence ends and cover begins. One question hangs in the cool air of the control room. If everything here is only practice, why place the drill on an interstellar object at its most private hour rather than on one of the many safer, slower comets available next month? A second question follows like a shadow. If an answer exists, is it scientific caution, or is it a directive from stewards above the public briefings who saw something first and told the network to be ready without saying ready for what? We pause with an image that bridges to motive. The memo lies under a clear paperweight shaped like a small orbit. Outside the window, the horizon lightens. Inside, a whiteboard lists 3 words in quiet marker: timing, reconciliation, recovery. The next section asks why this target and why this moment, and whether choice rather than coincidence placed 3IATLAS at the center of the most careful drill of the season. The hour of closest approach arrives with a hush that does not feel accidental, a narrow corridor of glare where the sky turns bright enough to excuse delay, and the choice of subject looks deliberate rather than convenient. The curtain is real, the watch is real, and the decision to place an interstellar outlier at the center of a crowded schedule tells its own story. Begin with what does not need interpretation. 3IATLAS is an interstellar visitor modeled on a hyperbolic path, a little above 1, unbound to the sun and unwilling to stay. Perihelion compresses solar elongation to only a few degrees, so ordinary optics surrender and thermal loads climb. Detectors saturate, timelines slip, radio links narrow. All of that is normal. Against that normalcy sits a calendar entry that recruits many small eyes to behave like one coordinated mind. The window is short, the watch is dense. The memo says exercise. The selection says priority. If large institutions wished only to test coordination, countless safer targets exist next month. Main belt asteroids move slowly and forgive errors. Comets with predictable comet cross night skies far from the sun. A drill could ride an easy arc and still teach everyone how to reconcile positions and calibrate clocks. Choosing an interstellar outlier at the moment of worst seeing asks for more effort, more precision, and more patience than a class normally demands. It feels like training. It also looks like a choice wrapped in curriculum. The context of interstellar visitors matters. The first famous one taught us that small, non-gravitational pushes can masquerade as gentle drifts when geometry and outgassing align. Another taught us that chemistry born under a different star can complicate our spectral habits. A third object carries its own unknowns. Spectra can mislead when dust is sparse. Light curves can hide seams when shapes are odd. If a network wanted to improve its reflexes for this special category, it would select exactly such a target, difficult and instructive. That is the sober reason. It is also the convenient cover. Timing has a rhythm that returns to the same beat. The campaign asks for baselines before perihelion, recovery within a day or two after, and immediate reconciliation of residuals. Southern latitudes receive emphasis where elongation improves first. Longitudes are staggered so nights overlap and gaps shrink. Backup windows are booked in case weather plays tight games. The pattern looks like a drill that expects an answer quickly. The same pattern looks like readiness for a small deviation that would be invisible without synchronized clocks and fast reporting. Grounded speculation sits on those anchors without slipping. If someone wished to test a heat-triggered mechanism, a brief furnace is needed. Radiation pressure rises. Volatiles wake. A thin sail could stiffen and add a subtle push that a single sight might miss. A shaped plume could add a few meters per second at the point where velocity already peaks. A change that integrates into thousands of kilometers of a long track drift within days. No magic is required, only heat, timing, and a watchful recovery arc that does not blink. A single vivid image holds the scene still. In a control room that smells of dust and warm plastic, national clocks agree to the second while the sky outside glows pale. A whiteboard lists 3 words in tidy handwriting: timing, reconciliation, recovery. On another board, a simple sketch shows the blind arc as a narrow tunnel. At the far end of the tunnel sits the word reappear. Below it, a small box says compare. On the console, a thin stack of forms allocates contingency time on instruments that rarely take targets of opportunity. The room is quiet because everything that can be done has been done. There are innocent reasons to choose Atlas. Interstellar objects are rare, and practice should meet the frontier it hopes to understand. Analysts want to validate pipelines that handle unusual spectra and odd light curves. Teams want to see how software behaves when outgassing grows or fades quickly. Practicing around a hard target makes future science better. End of argument. There is, however, a parallel logic that sits beside it like a shadow. If you wanted to be ready for deliberate action, you would disguise readiness as curriculum. You would write a plain memo and place it on the hardest day. Numbers calm the pulse. Perihelion pushes elongation under 5 degrees. A change of only a few meters per second at that point becomes thousands of kilometers of position drift after a few days. 10 stations spread across longitudes lower weather risk. 2 or 3 in the south catch the first clean windows. 1 mid-sized spectrograph watches for fresh lines. 1 radio receiver listens for narrowband murmurs. Sub-arc-second astrometry exposes drift when many baselines are linked. None of these plans are exotic. They are also prudent. Institutional behavior has a texture. When nothing unusual is expected, documents take their time and releases flow in comfortable cycles. When something ambiguous is possible, language tightens and schedules align. A coordination memo that reads like choreography is not proof of anything by itself. It is a sign that people inside want to move as one, without saying why in public. The choice of an interstellar object under a solar curtain intensifies that texture. Reasonable minds can disagree about what that texture implies. Now the imaginative leap, and then we set it down. Suppose Atlas carries nothing like a sail or a plume. Suppose the only thing that wakes at perihelion is a chemistry that glows green and a coma that thickens because sunlight reaches ice that has slept for millions of years. The network still learns how to catch tiny shifts under pressure. The public still hears the word exercise and goes on with the night. Yet, if the object did choose heat to bend its path, no one would need to invent a new plan. The plan is already on the wall. When the light thins and the clocks agree, the next step is simple. We ask Mars what it saw, and whether silence was calibration, caution, or the ripple of intent. Mars is our mirror in the dark, a high window that looks sunward when Earth must look away, and tonight that window feels curtained, a view withheld until someone says release. HiRISE rides on a patient orbiter that loops Mars roughly every 2 hours. Its eye can resolve details near 30 centimeters per pixel, and its gimbal can point off the ground to glance into space. Frames pass through a pipeline of calibration, compression, and archiving before anyone posts them for general use. In quiet months, those steps take days or weeks. When cadence tightens and attention gathers, the same steps feel like a pause, asking to be interpreted. A camera that reads Martian boulders like text could also read a thin coma across black sky, yet the page stays blank a little longer. The geometry is why this lens matters now. From Mars, the Sun, and 3IATLAS trace a different angle than they do from Earth. A few extra degrees of elongation can be the difference between no data and a usable glance. A platform above a red horizon is free of our daylight and our weather. It can look during our blind hours and hand the network the first clean recovery when the glare thins. If you wanted to bracket the hidden arc with more than ground stations, a Mars-based eye would sit beside spectrographs and radio dishes on the planning table without needing any special label. There are ordinary reasons for quiet. Engineers prefer to release frames after flat fielding and updated darks. Star fields used for calibration can require careful alignment. Radiometric adjustments settle over several iterations, a week here, a week there. If a target near the Sun sits in the pointing plan, stray light complicates corrections and stretches the queue. A gap in public post can be nothing more than a queue. We say that first because it is true and because it keeps the mind from sprinting. 2 grounded speculations sit beside the ordinary. First, if pre-perihelion pointing captured a narrow smear of activity that does not match expectations, the team could run an extra round of checks to avoid an embarrassing misread. Second, If a sequence includes off-limb frames that happen to sweep over a moving point of interest, those frames might receive an internal review to understand whether the brightness pattern belongs to ATLAS physics or to instrumental ghosts. Neither scenario requires mystery. Both live comfortably inside prudence. Numbers cluster for sleep. Orbit period near 2 hours. Resolution near 30 centimeters per pixel. Downlinks bundled into a few windows per sol that move with deep space network schedules. A couple hundred megabytes to a few gigabytes per day, depending on other instruments. Public archiving that often lags by a few days and sometimes by a few weeks. 10 or so people on the shift that touches these frames. A small group of scientists who draft the notes that help non-specialists follow what they are seeing. The list is plain on purpose. Now the vivid image. A control room lit like late afternoon sits inside metal walls that creak when temperature changes. On one screen, a live attitude indicator shows the spacecraft holding still. On another, a directory tree scrolls with timestamps that cluster around the window, everyone circled in pencil. A still opens. It shows a thin wedge of space beyond the red planet's limb. Stars are pinpricks. A faint brushstroke slips across 2 pixels. Someone zooms until compression blocks complain, then leans back and writes a time on the whiteboard for later comparison. Nobody speaks loudly. Someone prints the frame and slides it under a clear paperweight shaped like an orbit. Solar weather offers a misdirection worth noting. Coronal outbursts rise and fall every month. When radio noise climbs and auroras follow, feeds fill with bright distractions. A maintenance cycle at a tracking complex can overlap such a spell, and the combination makes quiet look deliberate when it is not. On the ground, a seasonal dust front over Chile or a rain band over Hawaii can thin the stream of routine images. Natural noise can feel like camouflage when we watch too closely. It is wise to admit how often coincidence paints a mask over ordinary work. Return then to the link with our measured drill. If a Mars eye captured jet structure in the days before perihelion, those vectors would guide where the network points for the first recovery sweep. If a faint second point travels beside the primary, fragment, or companion, a properly timed stack would prove it quickly. If the coma chemistry shifted, a spectrograph on Earth would know which wavelengths to favor the moment elongation improves. All of this fits under the word exercise. All of this also looks like readiness that prefers not to say ready for what. The imaginative leap is small, and then it rests. A quiet directive could ask a planetary camera team to delay public posting for a short span and route frames to a restricted list that includes cross-network coordinators. The stated reason could be calibration. The practical reason could be to avoid early headlines before the recovery arc begins. Nobody needs a thriller inside the staff wiki for this to occur. In large systems, polite language is how decisions travel, and 2 layers often ride the same sentence without touching. Institutional texture carries clues even when facts are scarce. When corridors expect only routine frames, captions arrive in relaxed batches and social feeds tease a few pretty views. When corridors expect ambiguity, captions tighten and the space between drafts lengthens. A memo that emphasizes timing and reconciliation pairs neatly with a camera team that chooses to speak later rather than sooner. It is not proof. It is simply the shape of caution under a very bright sun, and it suggests that Mars may have looked on our behalf and chosen to whisper later. A soft bridge closes this clue. If an eye above a quiet desert chose to wait, what about the detectors that hear rather than see? A high-energy monitor does not burn in daylight. It hears when optics fail. If there is a signal whose cadence resembles a device rather than a comet, it would surface first where heat does not blind. That rumor carries a name and a date, and it is the next page we open, a muffled gamma echo that rose, then faded, then whispered at the edge of attention. A rumor moves like a low note through the hallways of high-energy astrophysics. In late September, a cadence in gamma data rose, steadied, then went quiet. Some called it engine-like in private, others called it coincidence, and nobody put their name on the email. Fermi keeps 2 ears on the sky. The Large Area Telescope listens from about 20 MeV to a few hundred GeV, and the Gamma Ray Burst Monitor listens from a few keV into tens of MeV. Both sweep in a steady survey that rocks the spacecraft so the full sky refreshes every few hours. The sun overwhelms optics in visible light, but gamma instruments tolerate daylight in ways that defy intuition. Earth's limb glows with showers of secondary particles. The South Atlantic anomaly interrupts data on each orbit. Trigger pipelines catch bursts and post notices through well-worn channels. And then analysts ask the old questions about localization, background, and whether 2 instruments heard the same event or different noise. What would an engine-like signature even mean at these energies? Not a single tidy line, because narrow lines are rare in gamma and response functions smear them. It would look more like a train of short, hard spikes, a mechanical rhythm carved into counts, or a quasi-periodic oscillation where a hardness ratio rises and falls on the spin of a small body. It could be a spectral slope that beats like a metronome for a short window and then dissolves. None of that proves intent. All of it asks for an explanation that stands after sleep and cross-checks. 2 grounded speculations stand close to the hardware. A rotating jet of outgassing, heated and shaped by geometry near perihelion, could modulate high-energy photons through small shocks, where dust and gas meet particles accelerated by the sun. A nucleus that turns every few hours could stamp that rotation into a weak cadence that rides the background. A second path is solar. Active regions produce gamma rays during large flares and during long-lived interactions, when energetic protons slam the solar atmosphere. When the sun is busy, a patch of sky can hum without any help from a visitor. Disentangling those paths takes more than a single plot. It takes localization, comparison with solar monitors, and patience. Now the image that refuses to leave. A night shift analyst sits in a quiet European office with blinds half closed and a mug cooling on the desk. A plot on the screen shows time-tagged events from the burst monitor, zoomed to a narrow window. Someone has overplotted a running hardness ratio. It climbs, dips, climbs again. A small note in the margin reads, Late Sep, 0318 UTC. Cross-check with LAT. The cursor hovers over a button that would send a draft circular to the community. The button does not get pressed. A second window lists internal tickets that ask whether the pattern survives new background cuts and whether a known solar episode overlaps the time. The minutes pass without drama. The plot stays open like a held breath. Numbers for sleep settle the mind. The Wide Field Telescope refreshes the full sky in about 3 hours. The burst monitor records down to microseconds. Its array uses a dozen sodium iodide detectors and 2 bismuth germanate detectors to hear a broad range. Typical triggers include short and long gamma ray bursts, soft gamma repeaters, solar flares, and terrestrial gamma flashes. The Earth limb produces bright backgrounds, and the anomaly over the South Atlantic steals several minutes on each orbit. Public latency for high-level products often runs a day or 2. Internal checks can add a week. A small group can gate a notice simply by asking for another pass through calibration. If someone wanted to hide something, they would not choose gamma rays. Too many instruments listen, and too many archives mirror the stream. That is why talk of a muffled echo should be handled with care. Still, a short window with ambiguous modulation can die in committee. If every explanation on the whiteboard has a natural version, and the calendar says the cleanest follow-ups will arrive only after the perihelion glare, a drill gives everyone permission to wait. It gives them a structure to gather cleaner points with clocks aligned and voices steady. Here's the imaginative leap. Brief and then set down. Suppose a device wakes only in furnace light and sheds microbursts of accelerated particles as it turns, shaping a comb of high-energy spikes on each rotation. The comb is weak. The spikes ride the natural background. The only sign is a metronome buried in a hardness ratio that persists for an hour and then vanishes. No one writes the word engine. Someone writes modulation consistent with rotation-linked outgassing and files the note for a joint analysis after recovery. Misdirection comes easily in this band. A magnetar can stutter with a hard spectrum and a confusing tail. A short burst can scratch a few seconds of the record and disappear into an afterglow no one catches in time. Solar storms can fatten background, while the true culprit hides elsewhere on the sky. In a month with lively solar weather, calibration teams stay busy and ground stations juggle maintenance windows. When noise rises everywhere, small patterns become negotiable. The safest choice is to speak later. The second safest is to let someone else speak first. There is a culture to caution. Data that tests assumptions needs more than one instrument and more than one pipeline. When a pattern appears that could be everything or nothing, committees choose the path that reduces regret. They schedule a coordinated recovery. They ask for cross-checks after the blind arc. They let a network gather fresh points when geometry improves, then decide which draft to release. A rumor remains a rumor because it has not yet earned the right to be a statement, and the language that survives is the language of patience. We bridge with a simple thought. Gamma rays are a strange way to whisper intention, while heat in the infrared is direct. A high-temperature plume glows where eyes tuned to missile launches listen at all hours. If a quiet web exists, it would not miss a furnace spark at Perihelion. The next chapter turns to sensors that see heat as shape and cadence as track. A shadow watch that claims nothing and records everything. The public rehearsal lives in daylight prose, but a second watch moves under low light and classified habits. It does not ask for volunteers. It does not post schedules. It listens for heat and motion in bands where the sun is loud, yet not blinding. And it keeps its own calendar for hours when a traveler might choose to act. Hard anchors first. Overhead persistent infrared systems stare from high orbits and scan wide swaths of the planet every few minutes. They are built to see the first seconds of a rocket, the re-entry glow of a vehicle, and the flash of a bolide that disintegrates high in the air. Their vantage points repeat on 12-hour and 24-hour cycles, with overlapping fields that reduce blind spots. Sun angles impose keep-out zones, but clever geometry and baffles allow grazing looks near difficult regions. None of this is secret in principle. The details belong to handbooks no one brings to a press conference. A perihelion passage is a poor time for optical astronomy and a decent time for infrared vigilance. Dust near a hot nucleus emits as temperature rises. Jets that open in heat produce filaments that a wide field sensor can catch as short-lived streaks against a cluttered background. Natural events have already proven the point. Meteor airbursts have been logged from orbit by their thermal signatures, and large rocket tests are cataloged by their plumes. If a network wanted to add a quiet layer of confidence to a civil exercise, it would place time on these eyes and ask them to watch a window where geometry forces everyone else to blink. Picture the room where this watch lives. No windows. A climate that smells faintly of coolant and paper. Wall screens show Earth as a map tiled in rectangles, colored by detection confidence. Small annotations mark persistent sources that move with weather or industry. A narrow strip near the limb of the sun is shaded, not forbidden, but flagged. A console displays a schedule that aligns with a civil bulletin by accident or by design. A technician sips from a mug and mutters about background normalization, while a supervisor highlights a 2-hour interval with a plastic ruler. Somewhere a printer adds a timestamp to a sheet that no one will ever post online. 2 grounded speculations sit neatly on those anchors. First, if the quiet web is cued by the civil exercise, it will focus on the early recovery hours when elongation increases even a little. That is when a fresh plume is most informative, and when a hot fragment would show a signature above the drift of background. Second, if a deliberate deployment of companions were to occur, transient heat spikes would paint a pattern that multi-vantage sensors could triangulate quickly. Neither speculation breaks physics. Both explain why an infrared watch would bother with a small object under a very bright star. Numbers gather to calm the mind. Geostationary altitudes sit around 36,000 kilometers. Highly elliptical paths complete in roughly 12 hours and hang over high latitudes for long dwells. Infrared payloads refresh their frames on the order of minutes, some faster, with onboard processing that flags outliers. Known clutter includes wildfire clusters, gas flares, and lightning storms that smear into predictable tracks. Detection thresholds for natural bolides sit high enough to avoid noise, yet low enough to catch kiloton-scale flashes. A cometary jet is orders of magnitude dimmer than a missile, but a long integration and a clean geometry can still mark a change if you know when and where to look. The point is not certainty. The point is to catch the hint that tells everyone else where to aim. Now the imaginative leap, brief and then set down. Suppose a mechanism sleeps in cold and wakes in furnace light, shedding a shaped plume for a short interval to add a few meters per second at the deepest part of the well. The plume is hot against a complicated background. A geostationary sensor sees a thin, bright line that appears and then fades as the geometry shifts. A second platform in a different orbit sees the same interval with a different parallax. The two lines intersect in a solution that points to a narrow cone on the sky. A civil network receives a polite note that says, "Prioritize this sector at reappearance." No one writes the word device. Someone writes elevated likelihood of fresh emission and sends it through a channel that never uses dramatic nouns. Misdirection is plentiful near the sun. Solar flares heat the upper atmosphere and push currents that glow in radio and infrared. The limb of Earth throws up its own signatures as day turns to night. Seasonal storms fatten the map with hot spots. In weeks like this, a conditioner failure in a server room can look, in a log, like a sky event because clocks slip and flags propagate out of order. A quiet web survives by assuming false positives first, and by queuing follow-ups only when 2 or more views agree. That culture of caution is why sensational claims do not leak easily from these floors. It is also why patterns of readiness matter more than any single plot. Link that culture back to the memo everyone can read. The civil exercise asks for immediate post-event submissions, rapid reconciliation, and reserve time on instruments that do not usually take targets of opportunity. A shadow web that watches heat would not measure trajectory directly, but it would provide a time-stamped hint that something non-trivial happened at the right hour. That hint, even if phrased as a dull phrase like thermal activity noticed, would justify the precision cadence in the recovery arc and the emphasis on clocks that agree to tight tolerances. Institutional texture tells you how the streams might meet. Where classification rules forbid a direct citation, a sanitized summary can travel as a weather note that changes nothing and alters everything. The civil side receives a sentence about elevated background or favorable conditions. The practical effect is a tighter focus on the sector that matters most. In return, the civil network's astrometry, gathered in the first clear hours, flows back as a clean track that reduces uncertainty for desks that cannot admit they were watching. Each layer claims it stayed in its lane. Each layer benefits from the other. One vivid image closes the loop. A 3-panel display shows time as a ribbon. Panel 1 is infrared counts minus a moving average. Panel 2 is a sky sector map with a faint star field and a shaded cone. Panel 3 is a list of observatory codes due to open at dawn in southern latitudes. A cursor moves from panel to panel. A whiteboard holds 3 words in careful marker: timing, reconciliation, recovery. The same words we saw on the civil side now live under fluorescent lights that never turn off. The open question is gentle on purpose. If you had 2 networks and 1 public reason, would you ever admit that the window mattered for more than practice? The follow-up is practical. Infrared cannot weigh a path. Only positions can. If the watch caught heat and the track after reappearance shows a drift of a few thousand kilometers over several days, the conclusion will emerge without drama. If nothing moves beyond noise, the same logs will file under routine. Either outcome justifies the attention, and either outcome keeps the lullaby of caution intact. We step now from watchers to consequences. If a traveler chose the furnace to add speed, that choice would leave a fingerprint on the sky that careful clocks can find. The next chapter takes that possibility apart with patient numbers. We ask how a small push at closest approach would bend a hyperbolic road, how many baselines reveal it, and how a network that calls itself a drill is already positioned to measure the nudge. Perihelion is the furnace where small choices matter most. A traveler that changes speed by only a few meters per second at the hot point can alter its energy far more efficiently than it could in the dark outer arc. This is the Oberth effect in plain clothes. Speed is already high near the sun. Add a little more there, and the energy term multiplies. Add the same push in a cold, slow region, and you waste it. If someone wished to bend a hyperbolic road without drawing attention, the brief glare window would be the logical hour. The curtain is bright, the cameras are tired, and the physics do the amplification for you. Begin with anchors that do not argue. Orbital energy depends on velocity squared. So, a tiny delta at high speed buys a larger change in energy than the same delta at low speed. Near a tight solar pass, a small body can move tens of kilometers per second. Add a delta of 2 or 3 meters per second there, and you nudge the specific orbital energy enough to shift the line that predicts where it will be days later. The effect does not leap off a single frame. It unfurls in the along track direction as a gentle drift. That is why careful clocks matter, and why a network that calls itself an exercise asks stations to bracket the blind arc with precise positions and to reconcile them fast. We can sketch how the watch would catch it. Before the glare, observatories gather a dense string of astrometry with residuals under an arc second, tied to Gaia stars and stamped with GPS time to the millisecond. They fit a solution and propagate a covariance forward through the blind hours. After the glare, the same sites and a few fresh ones pick up the object as elongation improves, using consistent filters and exposure times to control coma scatter. They solve again and compare the predicted track with the recovered one. The difference lives mostly in the along track direction. Cross-track changes mean a different push, like a side plume or a yawed sail. Along track changes point to a speed tweak at the deepest part of the well. The map on the wall does not show drama. It shows a new line shifted by a few thousand kilometers after a few days, and a quiet room that understands why. Numbers for sleep keep the pulse steady. Imagine a perihelion speed around 70 kilometers per second and a push of 3 meters per second. The fractional change in speed is only about 5 parts in 100,000, yet the energy change scales with the product of speed and delta speed, which is why it matters here. Over 2 or 3 days, a tiny change of velocity can grow into an along track displacement measured in thousands of kilometers. Subarc second astrometry over 10 or more sites makes that displacement a measurable quantity rather than a story. The cadence might be 30-second exposures in a red filter to reduce atmospheric scatter, with timing accurate to a few milliseconds. 2 or 3 southern sites see first. Northern sites follow as geometry opens. The reconciliation session happens within a day. Grounded speculation sits neatly on those anchors. If the mechanism is natural, a jet that opens under heat can gift the nucleus a small push aligned with its rotation. If the mechanism is designed, a sail that tightens under radiation pressure for only a short interval can add a similar push with better control of direction. The numbers are the same at the level we can measure from Earth. In both cases, the signature is an along-track drift that appears as soon as the object re-enters comfortable elongation. The public language still says practice. The private notebooks whisper that the line has moved. The vivid image arrives in a quiet control room. White walls. A soft hum from cooling fans. On a central screen, a blue curve marks the predicted path, with a faint halo showing uncertainty. New dots arrive one by one from observatory codes that feel like old friends. The dots land a little ahead of the curve, not far, just enough to draw a thin second line that walks away from the first. A small group leans forward without speaking. Someone writes 3 numbers on a whiteboard. Delta V estimated. Direction mostly along track. Confidence growing. A hand hovers over the phone that would call a colleague who does not come in at this hour. The hand waits because the cadence still has 3 stations to go. Astronomy has honest misdirections that keep us modest. Coma asymmetry shifts photocenters and can mimic a long-track drift if weights are sloppy. Tracking errors stretch stars and pull a fit. A poor choice of comparison stars nudges a solution by fractions of an arcsecond. That is why the memo everyone can read insists on consistent filters, on documented apertures, and on quick but careful reconciliation. The network is built to sand down systematic errors until what remains has to be explained by motion rather than by measurement. If the first sweep shows a nudge, the second sweep shows it again. Few things settle the mind like redundancy. A second band of evidence can join the dots. If a heat-triggered plume did the pushing, a spectrograph might see fresh lines the same night that astrometry shows the shift. If the push came from a sail, the light curve might show a gentle change in rotation rate or amplitude as the sail conformed and then relaxed. None of these signals are proof by themselves. Together they sketch a consistent picture. A change in path, a change in light, a change in chemistry. 3 paths to the same hint that something happened in the glare. Now the imaginative leap, brief, and then we let it rest. Suppose a device was timed to open for only a minute, near the deepest point, and then close. The sail tightens, gains a fraction of a meter per second, and locks. The coating vents, gives a shaped plume, and stops. The action is invisible in the glare. The only clue is the line that people draw later, and the cold numbers that refuse to land where an old fit said they should. No press release says engine. No scientist writes that word in a public note. The phrase that survives is measured deviation within expected uncertainty, with a paragraph about possible natural drivers, and a quiet sentence that calls for continued monitoring. The question that stays with us is gentle and practical. If the line moves by a small but real amount, and the network announces the result in careful language, will we hear the nuance beneath the caution? The follow-up is simpler. Even if nothing more appears, was the attention wise? A traveler that teaches you how to catch a subtle nudge at the worst time of year is a teacher worth the long night. The next watch looks for fragments or companions, because a change in path is not the only thing that a hot hour can produce. The sky makes small groups when ice opens and when designs deploy, and the same net that catches a shift can also count new points of light. The room dims a little as dawn moves across longitudes. Screens roll their plots. Phones stay face down. The board keeps 3 words in steady marker: timing, reconciliation, recovery. Outside, the sky's ordinary. Inside, a thin line has moved, and the world has a new reason to stare at an old corridor. The furnace of perihelion does more than bend a path. It can open seams. Ice near the surface warms. Pressure finds a weakness, and a nucleus that seemed whole the week before can shed pieces that fly apart at walking speed, while the glare hides the moment of birth. A network trained to call this a drill is exactly the tool that counts what the glare conceals, because fragments advertise themselves not in the instant, but in how they drift and glow when the curtain lifts. Begin with anchors. Natural splits usually give relative speeds of only a few meters per second. After 2 or 3 days, that becomes separations of thousands of kilometers, which on the sky is a handful of arc seconds to a few arc minutes depending on distance. Fresh shards are faint. They may lag by 1 to 3 magnitudes compared to the parent and can fade quickly as surface area crusts. Photocenters skew if fans of dust push unevenly. None of this requires intention. All of it produces patterns that a coordinated recovery can catch if cadence is tight and fields overlap. The memo's checklists read like they were built for this case. Shift and stack routines align on the primary motion to tease out companions hiding near the glare wings. Overlapping pointings make sure a faint echo is not clipped by a field edge. Consistent apertures reduce the risk that coma gradients masquerade as new points. Southern longitudes open first as elongation improves, then northern sites stitch the fragments into tracks. A mid-sized spectrograph waits to measure whether a small companion carries fresher gas, while a narrowband radio slot listens for a carrier tone just in case a shard talks rather than shines. Grounded speculation sits close to those anchors. If fragmentation is natural, spin-up from asymmetric outgassing can cross a threshold at exactly the worst time, shaking loose a slab that has held for many orbits in another star's light. The new piece lifts away with a speed you could match on a bicycle, then coasts beside its parent with a slow, graceful drift. Photometry dips and then rises as surface area changes. The color might tilt toward green if exposed volatiles vent into a new coma. If the event is deliberate, the numbers can look the same at first glance. A small package released on command will also separate at a few meters per second and sit like a faint leaf in a broad stream. Numbers gather to settle the mind. Think of imaging in 30 to 60 second exposures at a red band to tame scatter, with astrometric residuals under an arc second. 10 stations spread across longitudes trim weather risk. 2 or 3 in southern latitudes get first light. A pair of stacks centered on the predicted rate and direction can reach magnitude 21 or 22 on modest apertures if the seeing is kind. A separation of 3 meters per second yields roughly 750 kilometers after 1 day and about 2,000 after 3. At an inter-system distance that becomes several arc seconds, well within reach of careful point spread, function fits that refuse to let coma disguise a second point. Now the vivid image. A recovery frame arrives in a control room that hums like a refrigerator. The primary is a soft smear that has been tamed by a gentle radial profile subtraction. 2 residual peaks remain where there should be 1. They are close enough to argue with each other and far enough to tempt belief. The room is quiet while a technician drags a small box across the second light, and the software answers with a number that is not noise. The next frame from a site 3 time zones away repeats the geometry with a slightly different angle. Someone exhales and writes the separation on a whiteboard beside 2 older words that never leave the wall. Misdirection deserves its own paragraph because sleep scripts hold the mind gently by naming ordinary pitfalls. Cosmic rays scratch single-frame spikes that pretend to be stars. Trailing from imperfect tracking paints false doubles. Jet structure can throw a bright knot downwind of a nucleus that fools an unwary eye. To protect against these tricks, the exercise insists on overlap, on repeated detections with matching motion, and on deep blending that uses the known shape of the coma rather than wishful thinking. If a second point survives those tests across multiple sites, it is real enough to discuss without drama. Here comes the imaginative leap. brief, and then set down. Suppose what separates is not a shard, but a small package meant to wake only when heat is loud. It could be a reflector sphere that tests navigation by light pressure, or a volatile puck that vents in a controlled way to write a signature into the sky. The relative speed remains small. The drift looks natural. The difference hides in cadence and in behavior. A package might flash with a narrowband rhythm on a radio scan, or keep an unusually constant brightness for its size, because it is engineered to hold a shape. No one needs to say the word device to notice a companion that behaves just a little too neatly for a random chip. A second grounded path returns us to chemistry. Fresh surfaces carry different ices. If the primary splits naturally, a spectrograph may see new lines or a change in relative strengths as the fragment vents material that has not seen sunlight in a very long time. A deliberate release could fake this briefly with a coat designed to outgas on cue, but the decay curve would likely differ. The civil network's plan to collect fast spectra during the first clear hours is the right way to tell these tales apart. A brightening that fades over a few days with a color change leans natural. A steady point with a stubborn light curve and no obvious spectral story demands a longer stare. Institutional texture matters again. A real exercise would note a fragment and move on. A prepared watch would note a fragment and tighten cadence. Schedules would rearrange without anyone saying why. The verbs would be calm and precise. Reobserve, confirm, extend. The public would hear the plain version. A secondary component has been identified. The internal summary would include a line about separation speed, phase angle effects, and whether the small one keeps its place in a way that suggests mission rather than accident. Both texts would be technically honest. One would carry intent between the lines. The closing question is gentle enough to keep sleep. How would you tell a natural family from a purposeful one when both are born in the same glare? The answer is in patience. Natural shards evolve like weather. They change texture, brightness, and color with time. Purposeful companions try to hold constant, or they repeat a small behavior when the geometry repeats. The next section leans into light and spectra, because heat writes its signature in colors and in lines as surely as motion writes it in dots. If something wakes at perihelion, it will glow in more than one way, and the network that calls itself a drill has already set its filters. Light is the only witness that can cross the curtain, and emissions are its fingerprints. When a traveler passes through furnace heat, brightness, color, and spectrum can change in ways that speak before trajectories do. A civil memo that calls itself an exercise creates permission to mobilize every kind of eye, not only to measure position after reappearance, but to listen for a sudden flare, a new line, or a quiet carrier that would not belong to a routine coma. If something wakes only when the glare is loud, the first story it tells is written in photons rather than in dots on a map. Hard anchors first, and they sit calmly. Photometry can track magnitude changes to a few hundredths with careful apertures and stable seeing. Spectra of comets often show CN near 388 nanometers, C2 in the green, OI around 630 nanometers, and sodium near 589 nanometers, with near-infrared bands that swell when ice is open. Natural brightening near perihelion is normal because fresh surface vents and dust scatters more sunlight. Radio work adds a different ear. Broadband surveys sweep tens of megahertz to a few gigahertz and can notice a narrowband tone if it repeats. None of those signals is alarming by default. All of them help separate drama from design. Grounded speculation leans in without leaving the floor. If a heat-triggered mechanism exists, a light curve might show a step rather than a smooth arc, a small plateau at the moment when a device engages and then settles. A spectrograph might record an unusual ratio among familiar lines, like sodium swelling while sand stays quiet, or a transient line that fades faster than a natural volatile should. A radio spectrogram could carry a slim line that returns with a nucleus spin period. Each possibility has a natural twin. Sodium tails can surge under sunlight pressure. Rotating jets can stamp periodicity into light. That is why the cadence and the cross-checks matter more than a single pretty plot. This is how the watch would try to catch it. Teams agree to use the same filters, the same apertures, and the same timing marks. Then take rapid sequences in the first hours after elongation improves. Photometry runs in blocks that favor stability over depth, so small steps are not mistaken for seeing noise. Spectrographs choose moderate resolution where lines are clean and integration times stay short, so shape and timing can be compared across sites. Radio groups sweep with slow, methodical scans rather than chase wide ranges. The aim is not a heroic spike. The aim is a set of small effects that agree with each other across distance and method. A vivid image anchors the idea. In a room that smells like warm plastic and coffee, a stacked image of a pale coma looks ordinary until a technician hits a key and the spectrum rolls in with fresh ink. The green band that belongs to familiar molecules swells a little more than expected. A thin trace near 589 nanometers rises for 6 minutes, holds, then eases back toward baseline. On a second screen, a radio spectrogram shows a faint comb with teeth separated by the approximate spin rate that photometry suggested last week. No one says the word engine. Someone writes the time, the duration, and 2 letters for site codes that saw the same thing, then draws a small box around them so the reconciliation team knows where to start. Numbers for sleep keep the pulse steady. Moderate resolution around a few thousand resolves. Bright optical lines without wasting light. Slit widths near 1 arcsecond balance throughput and sky background. Signal to noise ratios of 20 to 50 let small changes stand above noise without inviting overinterpretation. Photometric cadence at 30 seconds to 1 minute can sample steps without missing the shape. Radio sweeps can scan from a few hundred megahertz to a few gigahertz in slow passes, with fast Fourier transforms over tens of thousands of bins that return a power spectrum every second or two. None of this is exotic. All of it is good practice for a hard target. Misdirection gets a whole paragraph because the sky loves it. Solar activity can pump sodium and change color balance. Charge exchange between the solar wind and neutral gas can write soft X-rays and ultraviolet in ways that leak into optical behavior. A dusty jet can mimic a carrier if its rotation is tidy and the integration window is short. Instrumental ghosts can produce ripples that copy the shape of design. The cure is repetition. If 3 sites see the same small step at the same time with different equipment, it is harder to blame a ghost. If a radio line repeats with a spin period and does not track any known transmitter or satellite pass, it moves from rumor toward report. A second grounded speculation looks at the chemistry itself. Fresh surfaces at perihelion can flip the balance of species. CN can lag while sodium surges, or the reverse, depending on what layers open. If an added heat source focuses on one patch of the nucleus, outgassing can become asymmetric enough to change both light and motion. An honest watch expects such behavior and labels it as natural until a pattern survives the most boring explanations. That is why the civil memo ties spectra to timing and asks for reconciliation within a day. The faster patterns are compared, the less time rumor has to outrun method. Here's the imaginative leap, brief, and then it rests. Imagine a small thermal chamber tucked inside a shard or a package, set to open a vent only when measured heat crosses a set point. For a minute, the chamber releases a trace gas chosen for a bright, clean optical line, not for signaling but for calibration of a mechanism. The release adds a whisper of thrust while also painting the spectrum with a flicker that matches the spin. To outside observers, it looks like an odd line that rises and falls with a regular rhythm, then vanishes when the chamber closes. The same schedule repeats if the geometry and the heat repeat. No new physics, no magic, just a neat behavior that lives on the edge of plausibility. Institutional texture smooths whatever truth emerges. In a public note, a team would write that brightness increased by a small amount, that line ratios shifted for a short interval, and that possible causes include rotating jets, fresh volatile exposure, or sodium tail dynamics near perihelion. In private, the same team might add a clause that says the timing aligns with a predicted window and that the pattern repeats. The network format allows both sentences to be honest without forcing anyone to say more than necessary. The word exercise stays on the page. The behavior earns a highlight in a quiet channel. A soft question drifts in to close the scene. If a small device wanted to speak without being named, would it borrow a natural alphabet of light and rhythm, then use a cadence that blends into the sky's own pulse? The practical answer is that the next watch will look for consistency. Natural flares fade or evolve in days. Designed cadence repeats when the geometry repeats. The moment the world turns its eyes back to positions, the same instruments will keep listening for color and tone. Because a nudge in the path is only half of a story if a glow in the spectrum accompanies it. We draw a short bridge to the hours ahead. If the exercise is only a drill, emission curves will read like weather and our notes will file under routine. If a pattern reappears with the same timing and the same neat edges, a different kind of quiet will follow. Either way, the next act belongs to silence itself, the way institutions use it as a veil, even when their eyes are wide open, and how deniability becomes a tool when a watch was always more than practice. The phrase looks harmless on a calendar line, a polite label that reassures funders, press officers, and the public that what follows is practice, not urgency. In bureaucracies, names are tools. A drill can move people and point telescopes without implying fear. It authorizes long nights, prioritizes bandwidth, and lets managers rehearse the posture of confidence. When something needs watching at the exact hour when glare hides it, the word exercise becomes a key that unlocks action while keeping nerves steady. Hard anchors steady the discussion before speculation walks in. The International Asteroid Warning Network is a cooperative hub where observatories share ephemerides, photometry, and alert notes so planetary defense can keep a common clock. Coordinated campaigns are normal when a rare target appears or when geometry creates a narrow watch window. Tabletop rehearsals are standard across space agencies because the cost of confusion is high and the budget for errors is low. Perihelion truly is difficult for visible light astronomy. Solar elongation shrinks to a few degrees, detectors saturate, and reliable astrometry becomes a recovery task rather than a live sport. Language, however, carries strategy. A memo that begins as a planning note uses verbs that sound like a lecture, but operate like orders. Align, submit, reconcile, confirm. The checklists fold in contingencies that only matter when timing is tight. Reserve backup windows, queue rapid releases, pre-clear instruments that rarely take targets of opportunity. On a whiteboard, someone writes 3 words that appear in every paragraph of the plan. Timing, reconciliation, recovery. Training needs these words. Readiness breathes through them. There's also the shelter that words provide when the outcome is unknown. If nothing unusual happens, an exercise becomes a lesson learned, and a calm press note about best practices. If something ambiguous appears, the same word provides deniability. You were not hunting a secret. You were training. You were not mobilizing around a rumor. You were validating technique. The shift from practice to purpose can occur after the fact, without anyone admitting a change, because the name on the calendar never moved. A vivid image fixes the idea. In a conference room where the blinds never rise, a slim press kit sits face down beside a thicker folder marked with a neutral project code. The kit lists safe phrases for interviews about collaborative measurement and community engagement. The thick folder holds a schedule with small red hashes in the margin, beside 2 morning hours and a note about immediate post-event submissions. A projector shows a slide titled Exercise Objectives, while an identical slide on a second screen carries a private footer that says Priority Recovery. Nothing in the room sounds urgent. Everything in the room is tuned for speed. 2 grounded speculations follow without strain. First, a civil exercise is an elegant channel for sanitized hints arriving from sensors that cannot be sighted. If a quiet infrared platform saw a brief thermal cadence at the right hour, that observation could reach the public network as favorable conditions or elevated activity in a sector without naming the origin. Second, the exercise can shelter prearranged telescope time at facilities that dislike last-minute targets. The reservation looks like training on paper and acts like intent in practice. Numbers cluster to soothe the mind. Typical open records responses take weeks to months. Press teams prefer drafts locked 24 to 72 hours before release. A perihelion window of a few hours makes recovery geometry improve within roughly a day. 10 or more observatories linked by GPS clocks can stamp exposures to the millisecond. Subarc-second astrometry is achievable when coma is tamed by consistent apertures and filters. A push of 3 meters per second at 70 kilometers per second of baseline speed produces along-track displacements that grow to thousands of kilometers over several days. None of these numbers are dramatic by themselves. Together, they justify a net that calls itself practice. Institutions that live with risk cultivate quiet habits. Managers avoid verbs that sound like worry. They choose nouns that imply order. They let documents move through hands that keep drafts unsearchable until the timing is right. A call sheet might list participants for a rehearsal, while silently excluding the desks that tip the dominoes. A calendar invite might use a generic project name that means nothing in a public inbox. Behind the scenes, the same invite aligns with a row of time allocations that will not be advertised until after the watch has passed. Here is the imaginative leap, brief and then set down where it cannot run away. Suppose a crosswalk document exists that maps public language to private meaning. Exercise window maps to target of interest. Calibration cadence maps to sensitivity to short duration events. Post-event reconciliation maps to trajectory resolution within 24 hours. The document lives on a closed server, and no one outside a small circle will ever read it. Yet the behaviors it describes are visible on the surface. The civil plan is scrupulously polite. The tempo is unmistakably operational. Misdirection deserves a fair hearing because coincidence rides shotgun in space. Agencies run exercises because budgets demand visible readiness, and October skies bless many sites with clear weather. A drill that lands near perihelion can be defended as a lesson in hard geometry. Choosing an interstellar object can be defended as practice at the frontier. All of that can be true at once. The same schedule can be both a training plan and a veil that keeps the word concern out of the minutes. If the window passes quietly, the calendar reads like wisdom. If a pattern appears, the same calendar explains why everyone was already at their desks. The practical consequence of using exercise as cover is not scandal. It is speed. A network trained under a harmless name reacts without friction. Data flow has a lane. People know who calls whom. Clocks already agree. The first positions after reappearance land in the right folder. Spectra follow. Someone checks for faint companions with a stacking script that was tuned last week. Nothing heroic is needed. The decision to move was made when the calendar event was created, not when the sky delivered its news. A quiet question ends the scene without raising the pulse. When institutions must choose between scaring the public and missing a narrow window to learn, should they mask urgency as curriculum? The follow-up is softer. If they do, will the rest of us remember to listen for the difference between a lesson and a posture? The next chapter leaves the label and looks for the hands that wrote it, asking who actually steered the schedule and whose desk saw early data that made a rehearsal feel necessary. Schedules do not write themselves. Someone chooses a narrow hour, someone chooses the word exercise, and someone decides which desks must sit in the light and which must work behind frosted glass. The pattern that has emerged so far looks less like a crowd moving by instinct and more like a quiet committee accepting the risk of being early rather than late. It is the shape of a decision that wants speed without panic, coordination without spectacle. Hard anchors come first. Planetary defense today is a web with civil nodes and mission desks that are trained to cooperate. International warning frameworks exist to share ephemerides, photometry, and alert notes. Space agencies and university observatories run joint campaigns whenever an unusual geometry or a rare object appears. Parallel to that, public architecture live national risk offices that monitor the same sky because impactors are not polite about borders. Infrared surveillance and high-orbit sentinels are designed to notice hot motion. They are not built for comets, yet they do not ignore them if a watch window aligns. None of this is scandal. It is ordinary plumbing that lets information travel without every step appearing on a public calendar. The texture of decision-making follows predictable lines. When everything is routine, memos move at a patient pace, drafts circulate for days, and interviews lean toward education rather than timing. When outcomes are ambiguous and windows are tight, language becomes crisp to remove excuses, and schedules begin to snap into place. The label exercise preserves the right to call it practice afterward, but the verbs tell you what the authors fear missing: align, submit, reconcile, confirm. Those words serve perfectly well in a classroom. They also make a good checklist for a night when the cost of delay is missing a subtle event that will never repeat. Two grounded speculations sit just beyond those anchors. First, a civil bulletin can be tuned by influence from desks that cannot be quoted. If a quiet infrared platform logged a short thermal signature near the hours that matter, a sanitized hint might encourage the network to wait a sector or a time without naming why. Second, telescope time at facilities that do not entertain last-minute requests can be secured in the name of rehearsal precisely because someone senior expects that the first clean frames after glare will be valuable. Neither path requires drama. Both are consistent with institutions that prefer to be ready and unremarkable at the same time. Picture the room where such choices are floated. The walls are pale and the table is scratched by years of laptops. A small clock on the wall shows 3 time zones at once. On the screen, a slide titled Coordination Objectives shares a frame with a second slide that carries a private footer about priority recovery. A program manager speaks in even tones about calibration cadence and data reconciliation. A second voice, less public, points a pencil at a 2-hour band in the morning and suggests that instruments with flexible schedules keep it clear. No one says the word concern. Everyone writes the same hour into their notes. Numbers settle the mind while they hint at motive. A perihelion blind arc lasts only a few hours. Recovery can begin within roughly a day as elongation improves by a few degrees. 10 or more observatories with GPS-disciplined clocks can timestamp to the millisecond and deliver sub-arc second astrometry when filters and apertures match. A delta of 3 meters per second near 70 kilometers per second of baseline speed will drift into thousands of kilometers of a long track displacement over several days. A spectrograph at moderate resolution can catch fresh lines as soon as light returns. An infrared watcher in high orbit revisits a sector every few minutes. These rounded facts justify attention, even if nothing unusual happens. They also show why a schedule that looks like training would be reused without changes if something slightly non-routine occurred. Here's the imaginative leap, brief and then set down. Somewhere on a closed chat, a single sentence appears from a desk that speaks in weather words. Conditions favorable during window B for fresh emission. Recommendation to prioritize early recovery. The sender cannot be cited. The recipients already have a civil memo on their desks that calls for exactly those behaviors. The sentence does not change the plan. It hardens it. A calendar line titled "Exercise" remains unchanged in public view, while, in practice, it becomes the polite cover for action that was already decided. Misdirection deserves space because bureaucracies produce it naturally. Budgets often require visible drills in the fourth quarter. Audits ask for documented rehearsal of crisis roles. October skies are kind to southern sights. An interstellar object provides a legitimate scientific challenge that looks good on a training report even if nothing interesting happens. All of that can be true while something else is also true. An hour that matters can be hidden inside a plan that sounds like school. If the window passes quietly, lessons learned will read like wisdom. If it produces an ambiguity worth a second look, the plan will explain why everyone was in place to see it. Institutional fingerprints are subtle yet repeatable. Press notes arrive with careful nouns. Calendars carry neutral project codes instead of evocative names. Invite lists exclude desks that might leak too much enthusiasm to social feeds. The civil side emphasizes collaboration and best practices. The quiet side emphasizes timing and reconciliation. Neither side lies. Each side presents a face that suits its audience while the behavior underneath remains the same. Speed without alarm, coverage without fanfare, a public name that keeps the temperature low. A vivid image closes the loop. In a glassed-in operations floor, 3 screens show 3 threads of the same story. On the left, a world map with observatory codes wakes, sleeps, and then wakes again as local dawns arrive. In the center, a narrow ribbon of time is highlighted on a timeline where someone has drawn a small arrow labeled "When the glare thins." On the right, a secure window lists clearance numbers for reserved telescope slots that will never be advertised. A marker on a whiteboard writes the same 3 words we have heard in every room: timing, reconciliation, recovery. The hand that writes does not shake. It does not need to. Intermediate ending. If a single quiet sentence can harden a public plan, the last question before dawn is simple and calm. Who will own the result when the curtain lifts? And will the word exercise still fit? The bright hour ends the way storms end on radar, not with a bang, but with a thinning edge. Elongation grows by a few degrees. The curtain lifts. Recovery begins. The calendar says exercise. The rooms read readiness. What waits on the other side is not drama. It is geometry, cadence, and the habit of writing numbers that either land where they should or refuse by a small but stubborn margin. Anchors first so the pulse stays slow. Light needs about 8 minutes to cross 1 astronomical unit. Perihelion glare fades within hours, not days. Southern latitudes get the first clean angles, then mid-latitudes follow. 10 or more sites, GPS disciplined and filter matched, stamp exposures to the millisecond and fit positions to sub-arc second precision. The earliest reconciliation can happen within a day. By 48 hours, the map on the wall either sits still or walks by a few thousand kilometers along the track. Nothing here requires new physics. Everything here rewards careful clocks. The net is already cast. Photometry runs in steady blocks to catch steps instead of noise. Spectrographs hold short integrations that can be compared across sites, looking for a color that tilts or a line that flares and falls. Radio teams run narrow sweeps with patience, listening for a carrier that returns with a spin rather than with a transmitter on Earth. The checklists are ordinary by design. Ordinary procedures catch extraordinary behavior when it insists on being seen. The watch does not strain. It breathes. Grounded speculation sits quietly beside those anchors. If a small push occurred in the furnace, the signature will be almost entirely a long track. A few meters per second near high speed becomes a measurable drift after a day or two. If natural fragmentation happened, the recovery stacks show faint companions holding a slow separation that fits bicycle speed. If a specific chemistry woke under heat, spectra log a tilt in familiar bands and then relax. None of these outcomes prove motive. All of them answer the practical question that the memo was truly written to solve. Did anything change in the glare that matters now? The image in the control room is patient and plain. A central screen shows a blue prediction ribbon and a set of new points that arrive one by one from codes spread across longitudes. They land almost on the ribbon, then a little ahead of it, then on it again. Someone writes a small number on a whiteboard and circles it. Another hand draws a second circle around a time that two spectrographs marked as a short sodium surge. Phones stay face down. Coffee cools. A technician whispers a time for the next sweep, and the room returns to the hum of fans and the tick of a GPS clock. Misdirection earns its own chair because it always sits in the room. Photo centers drift when a coma breathes. Tracking errors stretch stars and bend lines. Solar weather fattens noise. Servers reboot and pretend to be sky. That is why the word reconciliation lives in every paragraph of the plan. It is a promise to subtract ghosts before anyone names an outcome. Redo the fit with a different aperture. Cross-check with another sight. Repeat the spectrum with a second slit width. If the line moves, it will move again. If it does not, the thrill of almost will file under experience. Two institutional textures touch at the doorway. A civil network posts a brief note that recovery is underway, and that early positions agree with expectation within rounded tolerances. A quiet desk writes a sentence that reads like weather, but points to a sector for more attention. Neither text lies. Both keep the temperature low. If a small deviation solidifies, phrasing will remain calm. Measured differences noted. Continued monitoring recommended. If nothing persists, the same cadence becomes a lesson about how to do drills when the sun is loud. The difference is visible only to those who saw the whiteboards change. Here's the imaginative leap, brief, and then put away. Suppose there was a device that woke only for a minute, tightened a sail, vented a breath, and then slept. The only public sign would be a thin, consistent nudge in the along track direction, and perhaps a small, orderly flicker in a line that should not have such neat edges. No one writes the word engine. Someone writes a paragraph about rotating jets and fresh surfaces and adds that the pattern is interesting enough to watch again. The truth, if there is one, hides in repetition. Designs repeat. Accidents evolve. Numbers for sleep return to settle the mind. A 3 meter per second delta at roughly 70 kilometers per second of baseline speed makes a fractional change of a few parts in 100,000. Over 2 or 3 days, that becomes thousands of kilometers of displacement along track. Subarc second astrometry across 10 stations resolves it. A modest spectrograph at resolution of a few thousand resolves bright optical lines well enough to see a short tilt. A radio sweep across a few hundred megahertz to a few gigahertz can find a narrow tooth that returns with spin if it exists at all. These are round numbers. They are enough. The curtain lifts and the watch continues without a raised voice. Either the line sits still and the lesson files under routine, or it moves by the smallest amount that changes the story. And the exercise proves it was the right name for a plan that never needed to scare anyone. The lights dim a little for the final minutes, and the language softens. We pull back from keyboards and maps and let the orbit widen in the mind. A small traveler from elsewhere has passed through a furnace it did not plan. Heat writes on every surface, and every surface answers with light. The people who watched were patient. They chose simple words and precise clocks. They made a net out of long nights and modest instruments so that whatever crossed the curtain would be met without drama. That is a kind of kindness. It is also a kind of discipline. You can fall asleep to that discipline. Imagine the sky as a quiet sea and each telescope as a buoy with a steady lamp. When the wave of glare rolls by, the lamps keep time. One buoy reports a ripple. Another says the tide is ordinary. None of them shout. They write numbers and pass them along like shells placed on a windowsill. In the morning, someone counts the shells and decides whether the tide was special. Most mornings it was not. Some mornings it was almost. A few mornings it was just enough to make you stare a little longer. If the line keeps its promise and lands where it should, the story closes like a book you loved for the way it felt in your hands, not for the twist you hoped would come. You learned the rhythm of a watch. You heard how caution sounds when it is not afraid. You touched the patience of people who are paid to think about rocks and light and risk without losing sleep. That is a comfort. It means that quiet competence can hold the sky even when rumor and coincidence try to make it wobble. If the line moves by that small, telling amount, nothing changes in your room except the weight of the hush. You will hear phrases like measured deviation and continued monitoring, and you will know what they mean without anyone raising a flag. It will mean the plan did its job. It will mean that a question appeared exactly where geometry said it might, and that the answer will arrive in slow sentences rather than in breaking news. That is a comfort too. It means that even our surprises can be handled by ordinary hands. So let the mind step back from perihelion and cadence and reconciliation. Let it float above a map of night where southern mirrors wake first and northern mirrors wake after. Breathe in for 4 counts and out for 6. Remember that curiosity is allowed to rest. The object will keep going. The sunlight will keep falling. The records will keep their dates. If there is a secret here, it is that the universe does not hurry and does not explain. It offers a glow, a drift, a color that leans and invites us to look without fear. Now the room is quiet. The watch has moved from glare to recovery, and from recovery to routine. You can close your eyes and keep the picture without the tension. A small traveler crosses a wide sky. The numbers file themselves in careful hands. The sea of night is flat and kind. Somewhere a clock on a wall keeps time for people you will never meet, and that is enough. Sleep meets them halfway. The stars will still be here when you wake.